Okay, welcome everybody. Thank you for joining us. This session is called the UC SDN, the future of networking. And I hope you're going to enjoy this. We have a panelist with me. I'm your host. We have some really incredible innovations we're going to show you. These are actual shipping products in most cases. And I'll let each partner present their solutions and offerings. So what I will cover initially will be basically basically what I'm going to cover is, let me start my timer. We're going to cover basically what is UC SDN, and basically each partner will actually get up and show you their scenarios around it, and even some video demos of shipping products. So I think you're going to really enjoy this. I hope you will, and please don't forget to fill out your reviews at the end. So let's start. And so basically, if you think about unified communication, and this is not just for Skype for Business or Link, this is across the whole, anybody who's deploying UC, there are a lot of challenges involved. And basically, if you think about it, we intentionally encrypt for a reason. We encrypt all our sessions, media, and signaling for security purposes, and that causes some poor visibilities. We also have dynamic ports on the media, so we don't use well-known ports. So trying to understand what a media flow is and signaling flow and understanding all that is very difficult if you're doing deep packet inspections in the network. So that causes a lot of poor visibility in trying to understand when a call goes bad, what's the cause, and so on. The other thing is, unlike consumer voice, enterprise voice requires that high quality, toll quality, carrier grade kind of voice. And to get there, enterprises must deploy quality of service. And there's complexities involved in doing that. The cost to deploy Quas, to maintain it, to operate is expensive. And it can be done, but it's very manually expensive. And so quality of service is very important. So that's another challenge. The reason why this is all coming to play is in the old days, if you had a telephony interface with a phone set that was in the Ethernet jack and so on, and it didn't move, and you can provision that on its own VLAN and its own EF voice cube, things were great. But in the UC world, you're on Wi-Fi, you're dynamic, you're mobile, you're spitting out voice video data packets. So this is very complex to manage. BYOD shortcomings, I already explained some ideas. BYOD is the thing. Wi-Fi is the norm now for connecting. Making Wi-Fi work correctly is very critical. Drivers don't behave right on BYOD for real-time media. So understanding where the problems are on that poor call is everything. Network security, we're about to start seeing as we're connecting to the cloud. Security is a big thing. People are worried about. We're going into defense and debt. So understanding how to have these perimeters and how to get through these perimeters in an automated way is very critical versus doing the static policies and configuring them. And what we find is when we look at a bad call and a poor call, what we find is that the majority of the poor calls that you see as not working right is, and I'm being very conservative at 60%, is really due to the network. The network not working right, not configured right for various reasons. I'm not going to get into it. Is a very important aspect to understand and try to figure out where the problem is. Is it the UC infrastructure? Is it the handset? Is it the driver? And is it the network, which is a high probability? Where in the network, like a queue not working right, not provisioned right for the right EF class of bandwidth, for Wi-Fi that is deployed wrong in the APs, and so on. There's a Wi-Fi session around this, and you should try to get to that on Thursday. I don't know the time and date, but I will be speaking on that with another colleague of mine. So let me go into what is UC SDN. We've always had a vision. We want to make devices, applications, and network play better together because we really want to remove the high cost to deploy unified communication from any vendor. Don't let any vendor tell you otherwise. There's a cost involved. And we want to make that as automated and seamless as possible, frictionless. So we always had this vision, make application networks play better together. If you look at software-defined networks, you see this general architecture. You see it everywhere. You see the applications talking down to this kind of intelligent layer called the controller, and then the controller abstracting down all that knowledge down to this network elements to southbound interfaces. And so the application has no idea about the network elements, just talks to central point, much like the SS7 world, if you think about it from PSTN, and then the controller magically just programs everything really awesome. So apps today, if you think of SDN as really orchestration apps in data centers, what we're talking is a whole new paradigm change. What we're talking about is taking those applications and making them end-user apps. What happens if end-user apps can program the network? What happens if they can communicate right down into this intelligence layer and communicate, and then that intelligence layer, like the SDN control layer, can program all the elements involved in that flow? This is what you're going to see from our panelists partners showing you all of this. Again, this goes beyond data centers. It goes into Wi-Fi, WAN, LANs. It's everywhere, and it makes end-user apps work better together with networks. And the great thing about UC is that we could do this because we have long-lived flows. A call half an hour, so this really works really well. The other thing I want to bring up is you don't have to replace all the bottom network elements to make this work. You just got to slide in this intelligence layer, and our panelists will talk about how you slide that in. So here are some very fundamental concepts, and I'm going to run out of time here, so I'm going to make it really fast. All of what you're going to see from our solutions run off this concept. We have a session that starts up for signaling, and then media starts flowing up, and right away we send an out-of-band web service to our network controller, okay, SDN controller, management control, whatever you want to call it, and it tells it about the session, the start of a session, what's involved, the IP addresses, media, voice, and so on. It's a rich, rich catalog of stuff. And then the controller takes that information and programs accordingly to the scenario to the network elements. So that's one construct to keep in mind as you start seeing all the vendor solutions, your partner solutions. The other one is what happens when we have a session running and basically during the session we have a problem. Can we tell the controller that we're having a problem so the controller can go and try to alleviate the problem and try to remove the problem is what we're trying to do on this. And so basically the problem goes away because the intelligence layer, this controller layer, knows there's a problem coming right from the app, and the app is telling that, and the controller can try to now remove that. And you're going to see some solutions that are actually working off that kind of idea. So that's another main construct. And then finally, what we're going through in the future is how do we bring in some of this intelligence back into up when there's a problem going on in the network? How can we bring it up to the application layer so we do call admission control and not let the next call go through, or change the codecs, put it at a lower pore bit rate, or don't use forward error correction if it's already congested, things like that. So it's a very powerful construct to have a bidirectional communication interface. So I'm going to go a little bit fast here because I'm going to be running out of time, like I said. It's a really jam-packed schedule. 6 partners are going to show you some incredible solutions. These are the 3 scenarios we're going after. Diagnostics, you'll start seeing that from a partner, or many partners actually, on this that will show you some of this. Automating quality of service, I talked about the quality of service issues. And finally, orchestration is the final futuristic, how do you orchestrate those defense in depth kind of layers of IPS DDoS systems so they all behave right and you don't have to put all these policies and rules in for UC applications. So we currently have been shipping this kind of model, and we've designed it for on-prem, for cloud, and for hybrid scenarios. So today, we're mainly on-prem, Skype for Business Server, Link 2013, 2010. We are adding this into our cloud. This will be part of our cloud, and then certainly for hybrid scenarios, half on-prem, half in the cloud, it'll work too. So this is what we're working towards. Our releases today, this is about a 2-year program already in progress, and we've been shipping this for 2 years, like I said, and we're already at version 2.11. You can actually go and Bing Skype for Business or Link SDN interface, and you'll be able to download this. You can install it on your front ends and bring up a SDN manager role, and it's all self-explanatory, and start working with this. This technology can be installed in 2013 in Skype for Business, and we used to support 2010, but you need a certain .NET framework, and we didn't want to go through all that and test it, so we just don't support it anymore. Highly scalable. We're actually running in our MSIT networks of hundreds of thousands. We're running some of this technology, and the load works, and it's incredible. And we spent 2 years to get this to a highly scalable, highly available platform. What else do I want to say? We're continuing to invest and advance this interface. So, standardization. I'm basically the chair of 2 standardized bodies around this. One is on the IMTC. We've got these use cases. You can go download this for free. I'll give you links on it. You just go to IMTC space UCSDN. You can download these use cases, 40, 50-page use cases on how to do automating diagnostics and quality of service. The diagnostic one's coming out. And then finally, we've liaisoned with the Open Network Foundation, which is the big SDN forum, and they basically are defining the specs. So we're already defined, the specs done. We've got reference code. We're building open source code. I'm going to put it into the open SDN, open source libraries that the ONF has created, and that will be available. So that's probably, we're looking to launch that in the next month. So it's very short to launch this. So now you'll have open source code to actually go and actually work with other systems and make that work. So in closing, what I'd like to say is basically the value of SDN is this. You could take a manual approach to get call quality and make it work flawlessly. You're going to throw people at it, and it's going to take long meantime repairs. What SDN gives you is an automated approach. It basically increases call quality, but you can do that through automation and lowering your OpEx, and then you get down your meantime repair because when calls do go bad, you know what's going on, seeing into it and finding it and fixing it really fast. Our key model that we go through is visibility, control, automation, agility. You get visibility first, you get to control, then you get to automation, and then you finally got agility. Okay, so that's basically the nutshell of UCSDN. And so I'd like to introduce our partners. One by one, they'll come up and they'll talk about their solutions and even do some video demos. So the first one is Michael from HP. So Michael, all yours.
All right.
And I've already reset the counter for you.
Thank you, Pascal. All right, so my name is Michael Zhu. I'm with HP. I'm the Senior Director of Global Solutions and Alliances, and at HP, I'm responsible for driving the strategic and innovative solutions across all the product lines from cloud, data center, to wide area networking, to campus wired and wireless and branches. I'm also responsible for driving global SDN ecosystem for SDN, and you will hear about it along the session. So Pascal did mention on the challenges as we want to take advantage of unified communication. And I'm not going to repeat it, but what I wanted to share with you is the HP experience. HP is today actually the largest link deployment in the world with 350,000 seats deployed and across 170 countries. And what we have found out, one of the numbers that I found very interesting is every month we Link actually give back 500,000 minutes of productivity to all the HP employees just because we can dial the conferences through web links instead of finding the number and enter the passcode. And we experienced personally how critical the network can make a difference for an improved end user experience, and the SDN solution plays a critical role. This is the HP view of how the SDN API and the link server works with our SDN solution. You have the application layer, which is the optimizer SDN app. You have the HP WAN SDN controller, as well as all the SDN-enabled HP infrastructure. And I'm not going through the different flows, but essentially, I think we're doing something that is quite revolutionary because this is something in the past decades people want to do, but have not been able to do until we have SDN. We always want application to work hand in hand with the network. But the network, a lot of the time, is device by device configuration. It's static policy. Dynamically is very, very difficult, and it's not scalable. But with SDN, we are able to put application at the center stage and really have the network to work for application. And that's what I want to call this is a great example of deterministic networking. It is not try to infer or guess what the application need to do. This is a very nice framework to have the application tell the network what it wants to do, and we configure the network for the best performance of the application. So here, I wanted to show you a quick demo. This is a recorded demo, and we will show you how our application is actually interacting with Link. This is the network optimized, the SDN app view, and it's sitting actually inside our SDN controller. We have all the information pulled from the SDN manager, Link SDN manager. So it's actually all the information we are getting from the application, and we can do the different things to optimize the experience. So if we go to this side, we are simulating kind of 2 calls between Fred and Sam. And we are trying to do an application sharing session. There is a video running on the desktop of Sam. And we are sharing that desktop with Fred. As you can see now, you can see the video on one desktop, but on the other one, it's really not working well, right? It's very sluggish. And if we move the window around, you will see on the other desktop, nothing is moving. It's a terrible user experience. So let's see how we can fix this. If we go back to the controller page, and we go to this SDN app session, if we scroll down, because you actually have all the information, the red bar indicates you have problems with quality of experience. And if we go to sessions, you can see actually all these sessions, these information all pulled from Link SDN Manager, right? And you have the caller and the callee IP information, and you have DSCP settings here. And down there, it's actually correlating with our controller information, the OpenFlow DPID, from the starting switch device to the other edge device. And we can see there is a desired DSCP and the layer 2 setting on the priority as well. So if we look at the application sharing, which is the problem that we were seeing, we actually have the setting in CS1 and the layer 2 priority 1. As we know, this is even below best efforts. This is essentially what's causing the problem. If we can go into here and bump it back up to the proper way of the priority setting of QoS, and normally for application sharing, you can put it at 32 CS4 and the layer 2 priority at level 4. If we apply it, and instantly, you can look at the videos, it's playing smoothly on the other desktop. And as we set this to the right level, every time you start a new session, you will be able to see the optimized experience. And once the call is over, the DSCP tagging can be released and the resources back to the network. All right, so I also wanted to touch on this, is for HP, this is the kind of the crown jewel of the solution, but we actually have a very comprehensive portfolio from the devices that is Link qualified to the best practice and reference architecture, from the storage, server, networking from data center to campus network. We even have routers with Link survivable gateway built in to the router and optimized and qualified with Microsoft Link. And we have TS services. That's what we found out with a lot of our deployed customers. We have dozens of customers deployed with Link and our SDN application. What we found out is for them to start the journey, they really wanted some kind of education at the very beginning. So the transformation workshop is really helpful, and network assessment services is really creating a lot of value for these customers. And this is one of the customers that has deployed successfully with Link and our SDN application. We have dozens of customers, and a lot of them, as early adopters, they are universities. I want to use this because we are seeing more and more customers like this. As a typical enterprise. This is a food manufacturer based in Tulsa. They have global operation, factories across 3 continents. One of their largest customers is McDonald's. They created this, essentially, this apple pie, pocket apple pie category. Every single apple pie that you eat at McDonald's, it doesn't matter where you are, which country you are, it's being manufactured and delivered by this company. And they rely on Link for global unified communications. They deployed this application. They are really enjoying a great customer experience. So the last one I wanted to say is actually quoting another customer. It's RMIT University. They actually just spoken in our customer advisory board as one of the customer advisor to HP. And they said the SDN deployment they have done is the least risk IT deployment they have ever done because of the hybrid mode HP support. If you see that the SDN network is not working the way you want it, you can always fall back to the traditional way of doing networking. And the other thing he mentioned is you can do it in such a granular level. You can do port by port SDN or OpenFlow enablement. So you don't have to do it all at the same time. You can really pick your own pace. And as you get more comfortable, when you get to Greenfield, you can always go to native SDN. That's when you can take advantage of the fully programmable, highly automated network. And that's where you will want a lot of innovative SDN application like Network Optimizer. And we are doing that with our HP SDN App Store. We launched that late last year with 5 apps, including the Network Optimizer. And now we have over 18 apps in the App Store. And we have 85 ecosystem partners. We're adding dozens this year. So if you want to check it out, go to hp.com/SDN/App Store. And we have a lot of apps being showcased there. Thank you very much. So let me turn over to Aruba. Christian.
Hi, Christian Gilby here. Are we on? Director of Product Marketing with Aruba Networks, partner of Microsoft. Our products are Link qualified. And I'm going to talk about our UC SDN integration today. So what's happening in the workforce today? Gen Mobile is really driving significant changes in the workforce. People are moving away from wired access at the desk. Have a lot of customers today. There was one I was out with earlier this year. They've moved all wireless. They've adopted Link, moved from a legacy wired PBX, integrating with UC SDN, and being able to be mobile throughout the workforce throughout the day and have quality of service delivered for their calls. So what are the challenges as I look at mobilizing and moving to a smartphone, a tablet, even a lot of the laptops today that don't have wired connections? The first one is, I'll talk about on the wireless side, is you've got density. We did some studies. Most people are carrying 3 to 4 devices in the office. So you've got a lot of devices coming into the network. We've got diversity. We've got multiple vendors of smartphone manufacturers, tablets. We've got compatibility things to look at. When I plug a headset into, say, a laptop, is it Link qualified, Skype for Business qualified to make sure the audio quality is there? So a lot of factors you have to look at to actually deliver it. In terms of the wireless design, where do I place my APs? What channels do I put them on? How do I make sure there's a good roaming experience? Because when I'm on my smartphone walking around the office on a Skype for Business call, I need to be able to seamlessly transition throughout the building and not have drop calls. QoS, I think, is the big one, and that's really what we focus on today in this talk is UC SDN. I need to be able to deliver QoS on the wireless network. It goes beyond the early days was just looking at, okay, how do I prioritize, assign the right QoS category to it? I also want to be able to monitor the traffic so I can provide an SLA. Be able to troubleshoot. When people call your help desk, how do I figure out what's going on and where the problem is? And that's where UC SDN API comes in, so I can actually dig into and look at the wired and wireless side of the network as to where the issues are happening. And then we also have to transition the wired network as well. So we're aggregating the traffic from the wireless that's coming through the switches. I need to make sure I deliver QoS on there. I need to be able to connect to my UC server and be able to monitor it as well on the wired side. And you can't fix what you can't see. So if I have encrypted calls running from my clients, how do I see what's going on? And that's where APIs like the UC SDN API come into play, where the infrastructure is able to understand what sessions are going on in the network without actually being able to decrypt the traffic. So how do we deliver end-to-end view and QoS? So what can Link Server do, Skype for Business Server with the SDN API? I can look at call origination type. I can look at call stats, call history. Now, if we look at the infrastructure side on the wireless, so if I look at the wireless network, in this case an Aruba controller and Wi-Fi, I'm able to do deep packet inspection. So I can look at what's going on and monitor the client traffic, look at QoS. I can also look at some network stats, diagnostics, which is great stuff. But it doesn't give me my view across from a session, from a voice call, what's going on the network. And that's where the UC SDN API comes in. So when we combine this with the wireless and wired infrastructure, what we're able to see is I can look at real-time monitoring of video and voice calls. So on a management dashboard, I can see where are my call sessions, and I'm going to walk you through that example in a few minutes here. Fault locations. So if I have call quality dipping, I want to know about it as an IT admin before I get people calling the help desk. Because one of the problems you get is oftentimes somebody has a bad call quality, they're not going to call the help desk. They're just going to suffer with it. They may switch from using your business extension to actually using their cell phone. And you don't want that to happen. So I want to be able to flag and diagnose those issues ahead of time. Client device issues as well. When I can see the connection from both the Link server side as well as on the wireless side, I'm able to now look at where there's potential client issues. And then finally be able to root cause diagnostic. Because wouldn't it be great if you can trace down from that wireless client through an access point to all the switches into the Link server. So now I can see, is the problem really on wireless or is it really on wired? And that's where the integration comes in, being able to trace across them. What do we get out of it when we integrate with it? So optimize Wi-Fi roaming. As I said, if I'm on a smartphone or tablet, I'm walking around. I'm not sitting at my desk. So I need to be able to roam between APs. And that means making the infrastructure aware there's a call going on. Because I don't want an access point going off channel to go and scan for rogues on your network when somebody's now coming onto that AP and on a call. So UC SDN API allows us to know and alert the APs, you've got a call coming on, don't start switching channels to scan. Priority. So now when I have a call on an access point, I want to make sure I prioritize that voice and video traffic ahead of somebody doing a file transfer, say an OS update. And then finally is the troubleshooting, which I think typically gets ignored a lot of times, honestly. QoS takes the main stage is I want to provide QoS, but you really need to focus on troubleshooting and be able to identify what's going on across those calls. How do we actually integrate? So basically the Link server, Skype for Business server, the UC SDN API connects through to the wireless controller, and then the controller talks with the access points to be able to assign QoS for a flow, and also up to the network management system, in our case, which is Airwave, and is able to report on it and allow users to diagnose it. What does it give you? Allows you to share that real-time call info and historical info, so I can look at, over time, what was my call quality across the network. Let's actually look into some examples here. So this is our management interface, which is taking the interface or the data that we get from the UC SDN API and graphs here. So on the left-hand side, it'll show based on protocol what calls I have going on. Some of these protocols are done by port number. Doesn't work if it's encrypted. The link sessions that you see on here, which actually in this example when we did it, it was all link sessions. Those were detected using the UC SDN API. So even if it's encrypted, we're able to see what's going on. I can also look at my device profiling, which is pretty interesting from an admin when you want to see where those calls are going on the network. from a troubleshooting. What's my mix of call qualities? Roaming. I think the most interesting one to me is this, which is the client health, and I'm actually going to zoom into that one. So what this is a graph of is on the bottom is your client health or wireless quality, and the vertical is your call quality, which effectively uses MOS that's calculated from the stats we get back from the SDN API. Up here is, so it's good quality, good client health. What's really interesting is if I see bad quality on the left-hand side here, it's probably a wireless issue, and I can start to drill into what the problem is. If it's in the bottom right, it's most likely not a wireless issue because my wireless quality is good. I can click on that call, and it'll actually drill down and show you all the switches along the path of the call. And we'll be able to report, for example, if there's any stats issues, for example, high packet drops from one of your wired switches or the wireless, and allows you to quicker get to the root of the problem. I can also overlay this on a visual map of my network. Because a great example is my last company, which was a voice company as well. One of the problems was we'd have employees call at IT at 3 p.m. Hey, at 2 o'clock, my call dropped. What are you going to do about it? And that's where the management comes into play, where we actually save the historical calls that go across the network. So if throughout the day my link calls go on, I will actually be able to look on the graph based on the color of the circle what the call quality was. More interesting is I can look back 2 hours and see, okay, Christian called, he had a call at 2 p.m. Let me set the time to 2 p.m. and look where he was. I can also, there we go. I can also trace as they moved around the building. So it's great for diagnosing when, okay, I have a lot of drop calls in this area of the building. Now I can start to look into, maybe I don't have QoS configured on that switch in that area of the building. Or maybe I have a coverage hole. I just haven't covered my wireless. So it really allows you to get to the bottom of the troubleshooting quicker. And I'm actually going to skip the video here. So effectively, yeah, now you're ready to basically cut the cord, move all wireless, integrating with the SDN API. If you want more information on our website, you can actually there's some engineering level docs that talk about how to configure UC SDN and connect to the Link server and configure it to be able to monitor. And thank you, and I'll pass it.
Okay. Good afternoon. My name is Joseph Fucciolo. I am the Chief Technology Officer for Nectar Services. We have a booth here at the show, so if anyone would like to stop by and learn more about this, we'd be glad to talk to you. And we're going to talk today about some use cases. And for us, we're slightly different. We're not an equipment manufacturer. We're a software monitoring and management diagnostics platform. And we're super excited, and we've been waiting for this innovation to hit where, for the first time, we really have an opportunity to make a change, to improve the user experience. So in our world, we start with monitoring, and unified communications is super complex. And what we're here glad to talk about is the fact that as much as we love our friends from Microsoft and we love being here, is that it's a multi-vendor audience, platforms out there. Many of the Skype for Business customers, Link customers have other legacy systems in their environment. And we're happy to say that we talk about the strategies. This is not, as Pascal mentioned, is applicable to the Avaya, to the Cisco, to other systems out there, to other SIP traffic. That way you could take this forward to your video conferencing systems and really make it ubiquitous. And so for us, we found ourselves in a unique position that we had a lot of interesting information from a lot of vendors out there in terms of what's going on, what's the call status is, what's the utilization. So having this wealth of information across the entire UC ecosystem put us in an interesting position. And we then jumped forward a couple of years ago. We started talking about real diagnostics. And Pascal and the committees have done a great job in formalizing diagnostics. When we use session data, and so our controller, our diagnostics engine, consumes that session data from the Link SDN API. And we also can get session start information from SIP sessions, H.323, Cisco Skinny, Unistem, Nortel. So it's extensible across about all the ecosystems. And we use that to allow our diagnostics module to understand call quality and real-time session readiness, and also track the sessions through the network. And so today, we've been shipping this for about 2 years. You can get a nice little picture. This is what we call a QSR, a quality of session record, where we'll pinpoint the problem. We'll say the little red triangle on here, if you hovered over that in the live demo, it would tell you what the fault was, and what we thought the problem was that caused the call quality to degrade on for that particular user. So the natural extension would be is if you can monitor and you can diagnose, can you remediate? What can you do about it? And so customers have been asking us for years, can you remediate? And the reality was we could have stuck our fingers in over SNMP to network devices and made changes, but that was a science project that no one would put to production because no one wants a third-party monitoring app putting their fingers into a Cisco or an HP switch and making changes. So SDN creates a place for us to do that in a safe way that people bless their APIs. So we've been very excited about it. So when you look at there we go. So use cases. Check my time. So we have a number of these initial use cases that we've been architecting, and again, this is what's great about, people say SDN, well, it's really futuristic, it's out there. And it's really a lot closer than you think. And unified communications happens to be one of the most ideal applications that could take advantage of it. And what's also great is you don't have to retrofit your entire equipment. You'll find is that many of the vendors, whether it's Cisco with their APIC EM or HP and others, and with OpenData is, you don't need to change everything. And you can use the fact that they can make configuration changes as a starting point to enable orchestration and on your path to full SDN. So these are our use cases that we've kind of defined out there, and some exciting things, real-time provisioning. So, when you ask customers, why is the network, they say, well, the network is messing with our QoS tags, or the network team doesn't want to trust the application. If you think about an IP phone that was on a dedicated VLAN on its own, and it was very easy to understand the profile. Well, now you've got a laptop, a tablet on the data network with other traffic mixed in, and it's a little scary to automatically start trusting the tags. What if a virus or a worm started tagging itself as expedited 46 and starts getting forwarded through the network? So network teams have always been cautious about, well, can I trust the tag? And today, you really don't have a choice. If you don't trust the tags, it's very complicated. SDN allows you to do is look at, well, they registered. We have a registration event. We've seen that person register to Link or system. Hey, they registered, they're real. We could program the network now to trust that device. Say, well, they just registered, they're real, they're authenticated. When they deregister, we can unprogram it. Or you can look at it on a per-call basis, so real-time provisioning. Another use case that we're programming today is looking at priority users. So video in particular is an interesting one where can you afford to give every user in the enterprise, 300,000 people in Hewlett-Packard, high-priority video? Can you actually enable that? So what you often see, we see customers doing is they put certain levels of executives or people that do video in certain classes or their room systems in certain class of traffic. And then other users are often in what they call scavenger or best effort. So video gets sacrificed, so be it. We just can't afford to give that kind of priority in the network, especially on wide area networks. So imagine a world where the network is aware, as we said here, where a call starts and the CEO call with some other folks or a high-level executive, and the network could say, we should raise the other queues up of those other folks on the call, bring them all up so we have a good experience. Or you have a link room system, which is high priority, and you have users that are non-high priority joining that room system. Raise the other folks up to guarantee an experience. Okay, so dynamic, true dynamic, and that's very exciting. Another use case, traffic modification and mission control. So call and mission control is very important because at some point, if you have too much traffic, you need to put your hand up to the application and say, slow down, no more. Downshift, speed shift. So being able to administer traffic, change call and mission control, and at the same time modify bandwidth priorities. And also if you have shifting environments, what if I would show of hands, I bet a lot of folks would have hard-coded settings for both voice and video and different vendors, and they'll allocate bandwidth per vendor. They can't look at it across the pools. So if your legacy PBX is shifting down and Link is shifting up, how do you realign your policies to that? SDN makes it, as we said, simple. And looking at QoS policy enforcement, this is another area we're focused on where the network could adjust itself, can detect who the users are, and then automatically adjust if we see misconfiguration. And so the video we're going to show is actually a real scenario, live, of a misconfigured traffic where we detect and fix it.
This demo is going to show you how the Nectar Policy Engine uses information provided by the Link SDN interface to fix a network problem using the Cisco APIC EM SDN controller. Imagine we have a user in Boston making a link call to a user in Plano. Unfortunately, the access switch in Boston is not properly configured. This causes the session to have quality problems. Immediately, this quality issue is detected by the analyzer in Plano as an event. It notifies the Nectar Policy Engine, which interfaces with the APIC EM controller to collect information from the network and fix the QoS misconfiguration problem on the switch in Boston. Let's look at this live. This is the APIC EM web interface showing that the voice class and the multimedia conferencing class are not properly configured. Here we see the dashboard of Nectar's UC Diagnostics product. The window on the top right corner shows the video call between the Boston and Plano offices. The window in the bottom right corner shows a log console so we can see when the policy engine executes. When the link becomes congested, the video freezes and the analyzer at the Plano site detects the problem. An event is sent to the policy engine, which collects configuration information for the APIC EM controller and identifies and corrects the problem. Here is another view of the same event showing the impact on the RTP media in real time. The bottom graph shows the media quality as experienced by the user in the Plano office. When the problem occurs, the video freezes and the MOS, or mean opinion score, drops to 2.19. The policy engine then uses the APIC EM controller to identify and quickly correct the problem. Once the QoS configuration is corrected, the call quality improves rapidly and the MOS returns to 4.38. The APIC...
So we use in that example APIC EM, that's a Cisco controller. We're also working with Open Daylight and other controllers out there. And again, this is, people ask all the time, well, how far out is this? It's here. And it can take some, you really can take advantage of it, and we're very excited about it. And look forward to talking to you folks. Thank you.
Hey everybody, so I'm Kevin Isaacs. I'm the VP of Engineering for Sonos. So today I'm going to talk a bit about what we're doing in SDN and network controlling. Ultimately, you're probably familiar with us, with Sonos in the voice gateway and the session border controller space. But when you fast forward as the world evolves, how applications interact with the network is as important as it is in how you connect outbound. And effectively, just to boil down what Pascal said earlier, 60% of the link issues are caused by networks. All right, so that's media quality issues. Now, when there's a link issue, do you think they blame the network or link? Or Skype for Business? I should get used to reprogramming myself on that one. They typically blame Skype for Business, right? They don't blame the network blindly because the network's invisible, right? So the way to solve that, and as we've heard already, is basically to leverage the UCSDN API to identify that traffic and actually correctly identify and configure the network. Now, our approach is a little different because we're coming at this as effectively a orchestration vendor, right? We don't make networking gear, right? We don't make switches, routers, etc. What we do is we make a network operating system, right? So it's got a controller piece, it's got an orchestration layer, it's got all the pieces needed in order to make all those functions fit together. And the way that it works is it works with OpenFlow compliant devices, whether it's like a switch from HP or a white box switch or any one of these devices that supports OpenFlow. And it provides intelligent, agile networks that can be dynamically and securely delivering it. And the dynamic and secure is very critical there, right? From our expertise as a session border controller, we know you only want to open up traffic when you know there's actually traffic there. You don't want to let rogue traffic through. So SDN can actually make sure that you're only opening it up once it's a real thing. So you can make sure that not only are you prioritizing the flows correctly, you're also securing the flows. So your network can be basically, and like on a university campus, for example, shut down and no ports flow until you know about the flow. So it gives you a whole new level of control over your network. It's a whole new level of really knowing that things are safe. We not only have the ability to open and control ports, right, for those IP heads, 5-tuple flows, we also have the ability to actually meter and control based on 64 kilobit per second increments up to 10 gig. And the system actually, and you'll see in the next slide, actually has a network-wide view to know what's going on in the network and what's connected to what. You don't have to go out, rush out, and buy all new switches, right? Because we realize that's a non-starter. Right? There's a lot of people that go, well, Kevin, I'm not going to run out and replace, I've got a lot of switches invested with Cisco, I'm not going to run out and replace those. Is there a way I can still deliver this? Absolutely. You consider it as a bookend, effectively, an overlay on top of it. Right? And it allows you connecting those together. And it solves that QoE problem, right? That quality of experience problem. You don't need to use QoS, but you still get the quality. So how does it work with Link? Effectively, you have the SDN Manager API that feeds over to what we call the Sonos NAS-IQ, Network as a Service Intelligence, and it actually controls the particular OpenFlow switches. So when a call comes in, and you're making it between two Skype for Business endpoints, it tells that SDN manager that tells ours to basically request it, and we open those pinholes, right? It uses the network topology, latency, and congestion data. So it knows all the sessions that are running. It knows FTP sessions, it knows web sessions, right? It knows how much is being used, because the switches are giving feedback of how much traffic is actually being used on it. And then we can make sure that we can actually put the particular flow in the right place, and you'll see that in a demo. We got fully automated network provisioning and optimization because of that, because the switches actually discover themselves. So we have a very clever algorithm to actually work through that, right? And that can enable QoS enforcement even if you don't have QoS, because we know how much bandwidth's on the link, so we can make sure we enforce that, right? The clients don't have to enforce QoS, the network's enforcing QoS, because you now have that link between the two. And UC traffic is getting priority, which real-time traffic has to get priority, right? Otherwise, you can have gobbling, et cetera, on it. And bandwidths are counted, right? It's all automatic, and you'll see that in the demo. What's critical here is that the automated quality of service works on that existing network. As I said, you don't want to actually go out and replace it. So what you'll see in the demonstration is a mock-up of a network. So like you can see in this real case, you've actually got a branch office, 2 different branch offices at the bottom, and a headquarters. And you'll have a mesh between them, right? Typically, you're going to have a mesh network between them. You often have the ability to go, for example, from San Francisco to Chicago via New York, just because even though that may not be the shortest path, it may have the least congestion. Because if you know what's going on in your network, you can actually correctly map the traffic around. So knowing how your network is actually mapped and having a full view of it is critical to actually doing it. And the NAS-IQ product basically has that application logic built into it to know exactly what's going on in the whole network. So it'll map it through. So your critical bottleneck is typically at the network edge, right, as it's feeding in. Because with your core, you either over-engineer it or you do have alternative routes. So as long as you have a way of mapping it through, you're good. Enforcing those policies, so saying that your real-time traffic is more important, it must be prioritized, that you bandwidth shape. So you've controlled that link so that you've got the, let's say your web, your Exchange traffic all sitting like, as a baseline, and then knowing you can fit a video call in, since video is the thing that drives most networks over the edge. Knowing how that's going to work is critical. And then making sure that you put in the right tags. Don't trust the client. Put them on the network layer. So even if it's dropped by your switches, you can still enforce it. and select, if possible, the lowest latency paths. Lastly, it is critical to interwork with existing IP MPLS networks. Right? Being able to switch to different label switch paths, go over different pieces, is very, very important. And be able to, and you'll see this is really, really important, is being able to take mid-call updates from that UC SDN API. So when something actually happens in the call, because you may go, well, perfectly engineer the network. But what happens if you have an outage on a link? What happens if you have some impairment on a link? How do you actually make it so that you can route around those particular problems? So with that, I'll actually take you into, I'll skip over the second use case, I'll take you into the demo. So what you're seeing here is you're actually seeing each router represents a different site. So what you're seeing to start with is we have a Skype for Business endpoint up in the top left-hand corner there, and a second one down in the bottom right-hand corner. So those are the two Skype for Business endpoints. And then we have a file transfer going in exactly the same path. So between those two sites, we have a file transfer running. What we're doing now is we're actually starting a Skype for Business call between the two. So it's a regular audio call. And there is enough bandwidth for that call to go. So if we actually go back into our management view and we check what path it's using, because we get a view of that, you can see the Skype call there, and it's going over the shortest route. Right? Very simple path, and the FTP is going over the same route. No problem, no congestion, we don't have an issue. Now, when we escalate to video, we get a mid-call update that says this video call's coming, and it requires more bandwidth than we know we have on that first link, because let's say that first link is a 1 megabit link. So what's going to happen is the system is going to go, I'm not able to fit it all in that first link. I'm going to reroute it over another link that may not be as short of a distance. So now you'll see that Skype call is actually flowing through that second one. So you can see it actually flowing through the second set. And now is where the whack-a-mole really gets started. Because what we're going to actually do is we're going to put impairment on that second link. So you can see where that mouse cursor is going around there now. We're going to actually put some impairment. So we're basically putting a WAN emulator on there, and we're going to simulate packet drop. And you see right now the video is perfect. And then as soon as the impairment kicks in, you'll see Dan's hand just freeze. So you see the impairment's actually kicked in at this point. So now the system goes, what am I going to do to recover from this? So the simplest thing is there another path I can use? So it's because the system realizes how they're all connected together, it effectively then reroutes and takes it over the longest path. And now the video cleans up. However, as I said, whack-a-mole, we inject on that area, we also stick impairment, and you can see it freezes again. So now the network operating system has to go, what can I do, right? Those two links are good. The only link that I know is good is the first one. And that first one has got the FTP traffic on it. So probably the best thing to do is put the video call, because that's the critical real-time one, on the first link and move the FTP. So you can see now the Skype has actually gone onto the first link, nice and clean, and then the FTP transfer has now moved on to the second link. So basically, all this is happening just with small drops in the video, and effectively nobody's the wiser that there was actually a problem with the network. So this is true self-healing and self-remedying networks, and this is all possible because of UC SDN. Thank you very much.
Good afternoon, everybody. Thanks for coming today, and I just want to thank Pascal and Microsoft for inviting us to come talk to you today. My name is Patrick Johnston. I'm the Director of Channel Sales for Extreme Networks. And you may be asking, why is the Channel Director up here talking to you? But I manage a team of a number of system integrators, large system integrators, and I also have a team of guys who are doing technology integrations, and those two tend to fit together. So a lot of these things that I'll get to at the end here are actually use cases that have come out of real-world experiences. And so when we first started talking to Microsoft, gosh, it's been, Pascal, maybe a couple of years ago or so, and we started to get some interest inside of our company about doing something with Microsoft and SDN. A lot of the sales guys would always look at me and say, well, don't you know SDN just stands for still does nothing. What are you doing there? So what I'm hopefully you're hearing today is you can't say that anymore. SDN is here, software-defined networking is here. It's going to be the networking protocols of how applications are going to interact with networks, and also how you're going to unlock and unleash a lot of the information that your network has to bring back to your application. So a very symbiotic relationship. And really what I'm trying to do here today is encourage you to come down to booth 367, or excuse me, up to 367. It's right up these staircases. We have some live demos working up there. Manny is up there, been working for a while. I've got a couple of my compatriots back here. We'll be outside afterwards. Come chat with us. But I just want to take you through some of the things that you've seen. I think Pascal summed it up really quickly at the very beginning. What are some of the challenges that we have when we're deploying any UC solution? You know, how do we increase user adoption? That's one of the big ones that we get a lot. And I think one of the other speakers mentioned it. If they don't like it, they're not going to use it. You know, they got cell phones. They got a bunch of other stuff that they can use for communication. So they don't necessarily have to use it, but you want them to use it because it's a low-cost solution. It's the company standard, et cetera. How do I deploy these? This is a lot of our integrators were saying, I want to put this stuff in. It's not a green field. There's a lot of switches out there. There's a lot of congestion out there. And it's not like the old networks where you have a single voice command. It's going over a lot of shared data. How do I simplify these deployments? And then once I do, when the dial tone goes dead or the phone quality goes bad, how do I know what the problem is? How do I know I don't need to upgrade the whole link? How do I know I need a new switch? How do I know that a server application went down? How do I get that kind of visibility? And sometimes I may not hear it from my users, but I know I need to do it, or it's going back to the first one, which is user adoption, and I can't have that happen. So again, what do we have? Users expect high-quality experiences, right? So they want to know that when they pick up the phone, they're getting that high-quality experience. This is what users are expecting. The guys who are deploying it and who are managing it, they want simplicity. We know it's complex. I'm not going to go into the details because you heard it from a lot of other folks. This is complex stuff. How do you make it more simple? And then also, it's when I put this out there and I load it up on top of my existing network, how do I know it's going to work? What's the certainty? How do I take that uncertainty of rolling these applications out? How do I get that visibility that I'm actually doing the right thing and that I can make incremental changes without guessing at what I'm supposed to be doing? So you've seen this picture from a lot of folks here. Those of you who don't know who Extreme Networks is, we've been around for a while. We have certified, we started off by certifying Link on top of our wired and wireless networks. We're the 4th largest networking provider in the world, if you haven't heard of us before. But what we're really talking about here today is our qualification and the certification we've done on the SDN controller. So essentially what you've heard from all the other, from anybody who's using this API, call comes in. As you know that there's a lot of dynamic allocation for ports. How do you know which port you're supposed to be giving quality of service to? If you're walking around in a building and you've got a cat video going on and the CEO video calls you, do you give quality of service to the entire device? And now you're sharing, a video bandwidth of your cat video your wife sent you with the video you're sharing with your CEO. No, you want to make sure that you're projecting those things and you're getting it down as granular as possible so that you're doing it. And you want to do it in a very open standard way. So the thing that we'll do is, while I'm showing you a lot of switches here from Extreme Networks, and we like that you use them, these work on top of any type of, we have an open daylight controller and anything that supports OpenFlow 1.3, which basically any switch you've deployed since 2005 will work in these environments as well. So not only do we do that quality of service, which you heard is so important out here, I'll show you a couple of screens here in a few minutes that talks about the contextual visibility into the call performance and call quality. So how do you know that it's happening? And how do you get that in a central location so I can see my network performance, I can see my call performance, and I can see other contextual information that the network, information data that the network is providing. And also back to the simplifying monitoring and troubleshooting. How do I go back in time and look at the quality that I was getting at one point or another? So again, so this is just a real quick thing. So some application of analytics and reporting. So not only do you want to see what's happening with Skype for Business, but how is it interacting with all of the other traffic that's out there, right? We're not looking at greenfield. If those of you who travel and go to football games and from the United States, you probably have seen that Extreme is the analytics provider to the NFL, or the Wi-Fi and analytics provider to the NFL. So you go to an NFL stadium, they actually, and log on to their networking, you'll be able to see everything that's happening in real time, over time, in an NFL stadium, by quarter, by minutes, et cetera, and you go back in time. And we'll see the same thing within your network. So are you seeing more traffic from a particular application, and how does that monitor over time, and what applications were consuming more bandwidth? And we do this through some deep packet inspection that we'll do at certain points, and we do some fingerprinting. But not only just your Skype for Business, but how is it interacting with your other traffic, in time, in the analytics. This is one that we always love to hear. Is we get the question a lot. Is what is the problem? You heard 60% of the issues that are caused are usually network related. And with the analytics that we provide down to the networking level, we can do just that. We can tell you, is this an issue with an application? Is it the application that's not giving us the response time, or is it the network? And then start drilling down on it and say, is it a particular port? Is it a particular AP? Do I need to upgrade that link from a 10 gig to a 40 gig, or do I need to upgrade the entire network? These are questions that can save you a lot of time and money as you're deploying these in real time. And then, the interactive reporting. We'll go into the controller and pull out a lot of the details. When did the call start? When did the call end? What was the duration of the call? Things that you can get a lot of reporting on. And have these done in reports. So the other thing that we can look at is what devices are they using? Is the adoption rate going to come over is it over a Google device, an Android device? Is it over an Apple device? Is it coming onto a particular OS? And you can start mapping these things out, who's calling who, and what type of devices are giving you the most trouble, for instance. So real quickly, forgot about this one. So network infrastructure reporting. So back into what is the network doing as well. So not only the types of devices as well. So I want to get to just a couple of use cases just to dispel the still does nothing. These are actual user cases that are happening today. City of Bellevue, I won't read all these for you. You can come look at it more, but these guys wanted to deploy this application, and instead of using weeks, they did it in hours. They got QoS deployed over 1,500 folks in just a few hours, getting QoS deployed end-to-end. Mount Mary University, the same thing. They were looking at both a wired and wireless, and they had BYOD devices that were not natively supported QoS. So how did they deploy that? This was the thing that they were looking at with their 1,500 users. And down for those of you from out of the country, we do operate there as well. This is a very large installation. And the interesting thing about this one is our APIs that we use in our network and the interactions that we have with our team not only are UC based, but a lot of on the security. So they actually have their Palo Alto firewall integrated in it the same way, such that if they're doing some nefarious issues, as we pointed out from before, you can get a message back from the firewall, shut that user down at the port on the application he's using, but then maybe send him a message on his iPhone that why you cut him down. So interacting these applications together. So we can get you more details on these later on. You can come upstairs. We have a fully functioning demonstration. It's a real live demonstration working up there. Manny is happy to see you. And me and my counterparts in our purple shirts will be standing out here after the session. So with that, I think I have to point this over there. And the next resources. Come see us in booth 367. There's a lot of videos that you can find on these use cases as well on our website. So do come see us. And with that, I think I am out of time. Thank you.
So good afternoon. My name is Peter Lee. So for the last few years, I have helped integrate programmable flow, which is NEC's SDN solution, into the Microsoft ecosystem. So this includes Windows Server, System Center, and now Link 2013. So since most people may not be familiar with programmable flow, before I talk about our solution today, I want to give a brief introduction to programmable flow. Programmable flow is an SDN solution built on top of OpenFlow. In programmable flow, you define independent and secure virtual networks called VTNs, which sits on top of any underlying OpenFlow physical network. Configuration in programmable flow is done against the VTNs on the PSC, short for programmable flow controller, and not on the network switches. Any changes in the network configuration are then pushed out by the PSC to the network switches, which can be either physical or virtual. The PSC also exposes a northbound API, which allows any application to program the underlying OpenFlow physical network. So this northbound API has been contributed to the Open Daylight project, and our solution uses this northbound API. So programmable flow SDN for NINC 2013 is a solution that uses programmable flow to manage the quality of service for NINC calls. So the solution will automatically ensure the quality of your NINC calls when there's network congestion. So currently, we manage quality of service based on NINC media stream types. So programmable flow SDN for NINC 2013 uses the NINC SDN API to get information about the NINC calls. So when a call is started, the solution is informed of the address information for the call endpoints. Using this information, the solution will program the PFC to be aware of these endpoints. So any subsequent NINC packets coming from these endpoints can then be acted upon depending on the policies that are configured on the solution. So actions on the packets could include changing the class of service for a packet and or assigning packets to specific network paths. So today I will show how you can use programmable flow SDN for NINC 2013 to ensure call quality is not impacted when there's network congestion by assigning different media stream types to different network paths. Before showing the demo, let's first walk through what we will be seeing. So in our demo, we have two NINC clients and various NINC 2013 servers. NINC SDN API is already installed in this environment, so the solution knows about the NINC clients. There's also a system running the NINC SDN app, which is our solution. So NINC SDN app knows about both NINC and programmable flow. You can use the NINC SDN app to set policies for different media stream types. In our network, we have various switches controlled by the PLC. They're both virtual switches and NEC physical switches. Even though in our demo we are using NEC switches, we have also tested this solution with switches from other vendors such as Dell. At the start of the demo, a call has already started between the two NINC clients. So all the media streams from this call are going through the same network path. Also, NINC SDN app is already running. And policies are already configured on the NINC SDN app and on the PSC to ensure the quality of the call on the network. With no other traffic on the network, there are no issues with the quality of the call. Next, we will inject background traffic to congest the network, affecting the quality of the call. PSC will detect the network congestion, and NINC SDN app will be notified to change the network configuration on the PSC. PSC will then program the network switches to look for packets corresponding to the media streams for this call, and assign a separate path for each media stream type. So let's take a look at the demo.
Zoom into the topology. Two link clients, two iPerf VMs are connected to switch 1 and switch 2. These traffic carry over the direct link between two switches. So let's start the demo. At the beginning, QoS policy is enabled and path map policy is not set yet. Path map assignment will be kicked in upon detecting the link congestion, which will be shown later. In the flow entry table, let's filter only link clients flow by specifying the source IP 52 and destination IP 53. All the flows are going through the same path number 1. This path continuously monitored by PFC's feature called traffic monitoring. Traffic monitoring is a provision with the threshold, rising watermark, falling watermark, and number of hit counts to declare, so that PFC will send an SMP trap whether it's congested or recovered. Back to Link SDN application window. 3 paths are already configured. to map audio traffic to pass 3, video traffic to pass 2, and application sharing to pass 1. P4 monitor service in the right window is running. While it is enabled, it acknowledges the link congestion status by receiving SMP traps. That will trigger a link SDN application to send a REST API call to PFC to provision 3 pass map. In turn, link traffic gets separated in accordance with the 3 media types. So let's generate the IPERF traffic in order to create the congestions on the path where link traffic is going through. This IPERF generates IP UDP traffic at 91 megabit per second over the 100 megabit link. Now, link SDN app detects the congestion and is going to enable the path map policy by calling PFC noseband API. Now let's see flows between the link clients again. Now the second flow is going through path 2, and the fourth flow is going through path 3, while the first and the other flows are going through path 1.
So as you can see from the demo, once the appropriate policies are set in the solution, the quality of the call is automatically ensured by changing the network path. So if we stop the background traffic, the solution can undo the changes that were made during network congestion so that all the media streams for this call will go back to use the same network path. So our solution can also ensure the quality of the call by changing the class of service for the packets. So using the solution, you can ensure that you do not need to worry about the quality of the call in the event of any planned or unplanned spikes in the network traffic. So if you want more information about this solution, please send an email to programmableFlow@necam.com. I will also be at the NEC booth in the expo area today to answer any questions you may have. Thank you.
Okay, guys, thanks for hanging around. I see quite a few people cleared out already. Anyways, I do want to have a call to action. As you can see, this stuff is real. Shipping products from partners. We're standardizing this. You can see some of the demos, the impact and the quality of what you can get by increasing quality. So I urge you to download the SDN interface. You can Bing it. You can trial it with these partner solutions in your labs and then eventually enable it slowly in environments. I would like you to specify this in your RFP processes. I think it'd be really beneficial for you. Thirdly, standardization. Join the IMTC and the ONF. We are standardizing this for close standards, and you can join us as a member. And finally, you can try these products out from the different partner showcases and their booths all over the place. So with that, I want to thank you, and we'll take any questions after the session. You can just come and talk to us up here. Our partners will hang around. So thank you very much. Appreciate it.